Okay, today on the bench from the M.H. Scott Company, we have a DAK 10, or DAK Mark X. Probably the largest CB radio ever made. I'd almost have to go measure one of the old Tram Titans. But yeah, they're not this wide. They're close. Height-wise, yeah, it's probably a pretty close match, but I think even this thing's wider. And it was meant to be just an impressive-looking radio. And that's kind of obvious because the inside, yeah, there's a lot of empty airspace inside this radio. Because it is not a, no, don't get me wrong, it has tubes, but it's not like an old tube type radio where they just needed a lot of room because the parts were a lot bigger and they needed the airspace. This only has two tubes. So let's just do a quick overview on it. Faceplate, pretty standard as far as controls go down here. Mic gain, mode, clarifier, channel selector, RF gain, squelch. On-off volume control. SWR calibrate control. Now it has two light panels right here with lights that switch depending on positions of switches here. So SWR, you can see it's actually showing SWR right there, or in calibrate. So it has a dedicated SWR meter. It's always on. This is a actually it's the only multifunction meter. Yeah. Actually, it is. It's the only multifunction meter. So this is either RF power in the upper scale or plate current in the lower scale. So you can see when you switch, that's some of the lights that change, RF power or plate current. And same for the mode selector switch. Has A&L noise blanker switch and light. Transmit standby, so you can see when you're in standby, the standby light comes on. And you'll see when if I'll let it off for just a few seconds, and when I flip it back on, you'll notice the lights blink. They'll go dim for a second. You saw that quick flash? That's because in that mode, you can't transmit. Now remember, vacuum tube driver and final in this thing. You're disabling basically that circuit. The filaments are still on. So all you got to do is blink and you're ready to transmit because the filaments are on, but you've basically disabled the high voltage power supply. And what that blink is you're charging up the filter caps and everything in the high voltage circuit. Has a selectable AGC, or automatic gain control, so you can turn it off, which is nice for sideband. You can turn it off, slow, or fast AGC. Has a dedicated modulation meter and dedicated signal meter. So like I say, it was meant to be just an impressive looking radio, really big. Lots of nice big huge meters, lots of knobs and buttons to play with. Is it the greatest radio of all time? Absolutely not. Do they have problems? Absolutely yes. They're known for having some problems, but it's nothing that can't be dealt with. At the heart of it lies a cybernet, so it's just a normal, standard cybernet board. Now, some people may argue that. I've heard people say it's a high-gain board. I've heard people trying to say what the board is. If you know anything about cybernet-built circuit boards, you can just look at it and go, yep, that's a cybernet, because it is an exact copy of the same exact circuit board you're going to find in dozens and dozens and dozens of different make and models of 40 channel AM sideband radios. So standard solid, like I say, cybernet board. The only thing is it does not have a cybernet part number on it. So the part number on this starts with something like, it's on the bottom side, so I can't see it at the moment. It was something like DT, where if it was a true cybernet, it would start with something like PTBM. And these boards were kind of known, and that depends on what vintage of DAK 10 you have. Some of these were known for having horrible problems, others not so much. This one had some problems. They're just, I don't know if I even want to say they're poor quality, but yeah, they just kind of seemed like poor quality. Not something you usually see with cybernets. So I don't know if these were specially made for, well, they obviously were specially made because they haven't, custom silk screening as far as the part, the board number goes. But I don't know if they were custom made for M.H. Scott, and maybe they're just lower quality. M.H. Scott, they only spec whatever. Cybernet and companies like Unit, and they just build whatever they're getting paid to make. But it's obvious to see this board was not designed to be in this radio, because you can see right here all of these missing parts and these two coax cables that come down. Well, that's because all of these missing parts, normally in a Cybernet, you'd see a shield around here, big aluminum heat sink, and you'd have a driver and a final transistor. There's no, actually the driver would be here and the final here. You'll notice there are none. That's because it has a driver tube and a final tube. So power comes out and in the board. Now the RF power just leaves the radio here, but for metering circuits and whatnot, they need to be able to send some of the, even your transmit power back onto this board, because you need to be able, for, like I say, for the meters and whatnot. But good circuit board. Like I say, this one, yeah, I get the feeling this was kind of one of those iffy ones, because yeah, when I was replacing the caps on this, it's obviously this thing, it had some work. It had bad solder joints. And that's not uncommon, and it's not a Cybernet problem. That's just the early double-sided circuit board. So if you see all these green traces here, okay, these light green lines, well, those are actually copper circuit traces. And there's, of course, circuit traces on the other side of the board. The problem is, unlike more modern boards, they have through-plated holes, and they're, your modern stuff's usually going to have a higher quality circuit board. The older, and like I say, this is not just a Cybernet thing, this is just an old CB radio thing. They tended to have cheaper boards. This isn't a several $1,000 piece of test equipment back in the day. Don't get me wrong, this wasn't by no means a cheap radio back in the day. But even still, it wasn't a $5,000 or $10,000 piece of test equipment. So, yeah, it doesn't have the best boards. So the boards can expand and contract a little bit. And what connects the top and the bottom layers of the circuit traces are a little, for lack of better terms in this radio, they look like nails. So it's basically just a piece of copper wire, or a cut-off terminal from something. It's about what it looks like. But the head's it's smashed flat on one end, so it kind of looks like a nail. They're dropped through the hole and then soldered to the trace on the top and the bottom side of the board. As with expansion and contraction, and you have different materials, you've got a fiberglass board, a copper pin, and tin lead solder, they expand and contract at different rates, and it can eventually pull and break those solder connections. So, and the best thing to do is desolder it and resolder it. If you try and just reflow it, yeah, I mean, that'd probably work fine, but how long it's going to last, yeah, maybe not, maybe not your lifetime. If you desolder, if you completely desolder it and resolder it with good solder, it'll probably last you the rest of your lifetime. I like using tin lead and silver composition solder, which gives it a lot more tensile strength. So top side, like I say, there's not a lot to the high voltage circuit. Can cap on top for electrolytics on the bottom. Low voltage power supply board here, and also your audio amplifier. You have audio amp here, but your audio amp over here as well. Now, another thing up here, light bulbs. And I don't mean light bulbs on the inside, I mean the light bulbs, and not so much for the meters, the light bulbs right here. Oh yeah, they can be a chore. Now, back in the day, probably would have been easy to change, because it would still be fresh and juicy. Well, after decades of use and just sitting around, the rubber grommets that those light bulbs are in have gone from nice squishy rubber to hard as a piece of gravel. And unfortunately, they also glued those light bulbs into those grommets with some really hard-ass glue. Most of the time, you end up breaking the backside of the bulb off trying to get it out. To complicate matters, let me just turn this off, the power supply off. I want to actually flip this up on its face really quick. I can actually show you down in here. Which one thing that's nice about the rack handles, you can just set the radio right up on the rack handles. So you can see we have these little plastic boxes, and actually I have, easier just to show you. Let me grab one. Of course, I have parts chassis of everything, and these are no exception. So I have parts chassis for DAK 10s as well, and they've already been dismantled. So this is what the little light boxes look like. Well, like I say, these rubber grommets, just like this one, it's hard as a rock. I mean, you can hear my fingernail. It's as hard as the plastic, if not harder than the plastic. and you can see they're glued in. And that glue, it is hard as a rock. You try and pull this out, the back of this light bulb just snaps off. Now you're stuck with a light bulb that's glued into that rubber grommet with no way to get it out. You can try and push it in, which is what I end up doing. Pushing it in, but then how do you get the light bulb out? You can try to take this out. The problem with trying to get this out is you stand a really, really good chance of breaking your meters trying to get this out. Because unfortunately, what holds this in, these two little tabs here, are the screws that hold the meters in. And actually, if I grab a meter, I can show you that too. Let's see, where are the meters? I think they're in another box. They're not in this one. Yeah, there's no meters in that box. They're in another one. The meters have the metal studs are molded into this black plastic in the back of the meter. And they have Loctite on them. Again, just basically the same stuff they used, whatever glue they used on these light bulbs is saturated on there. Now you can soften that glue up, but odds are you're going to break one or two or all of them. Because they're just so fragile. You'll try to unscrew that nut and it'll just spin and spin and spin and spin and spin. And that's because you've now broken the stud out of the back of the meter. So I try at all costs to never ever have to remove. I will do anything humanly possible to not remove one of these light, little reflector assemblies here. So if you break the back of the light bulb off, how do you get it out? Well, like I say, I just push it down through. Now, if you look on this one, I replaced two light bulbs. I replaced that light bulb and that light bulb. You'll see there's a little dark gray piece of something there. That's a piece of fish board or fiber board. It's a high voltage insulation board. I actually just cut holes in them. It may sound barbaric, especially coming from me to do something as brutal as that. Just whacking holes in shit. This is one of the few exceptions where that's the better option. This plastic is fairly soft. Just take a razor knife. You can just score it usually like 1 or 2 times, and if you push on it, it'll pop right in. You can cut a little window, which probably a piece of it. Yeah, here's one of them laying over here. So here's the one piece. You can see there's a little hole that was in it. Like I say, just take a razor knife, cut a little on all 4 sides. You see the little slit there. That's where I actually went in with a pair of needle nose pliers and just popped it out. Then I can just push the light bulb in, it falls down in, and then I can just take a vacuum cleaner and suck it out through the hole, and any dirt and debris that might have fallen down in that hole at the same time, because like I say, that rubber is hard as a rock and disintegrating. I can then put the light bulb in. Now I do use a little bit of glue. It actually does, these bulbs do actually fit fairly snug in there. And I use basically the same thing they had. Put my baggie of them out here. So, just standard, good, high-quality bulbs. These are not the cheap ones. These are the good ones with the metal base. But, stick them in there and just put a tiny bit of glue around the outside edge of it. Don't put any on the bulb and then push it in. You just want just a tiny dot, going from this back side down to the back of this plastic housing, just enough to hold it in. It's not like this thing's going into outer space, so it doesn't need, massive quantities of glue. That way, next time, years from now, when someone needs to change a light bulb again, all they got to do is grab it, and it'll just pull right out. A little bit of, quick twist, and it'll just pop right out of there. Like I say, now you're going to have holes open there. You don't want to leave that open because crud's going to get down into it. So you can use anything. Like I said, I just use that fiber board because it's rigid, works just fine for that, easy to cut with scissors. Just a little bit of glue around it covers the hole up. And again, if for some reason that bulb would happen to break off or something, or some nitwit would happen to knock it in, it would just be a matter of popping that thing off. And again, you can get into this assembly without having to remove it, because you really don't want to remove this. And then this bottom side here is actually held in by the toggle switches. So yeah, it's the backs of the toggle switch is actually set up over top of this. So yeah, it's a complicated way to hold something like this in, and complicated to get out. So it's just my personal advice. avoid at all cost ever having to remove this. Now let me get this stood up on its side. Let me show you the underside. Flipped around. Okay, so top side, lots of little orange wires. Yes, someone has done a channel mod to this, and that's you can only broadband these so far. Now the board itself is fully capable of broadbanding. It's a Cybernet. They do that really well. The problem is vacuum tubes. So whoop, we come down vacuum tubes. Yeah, they don't bend, at least in this radio. You can't get super broadbanding out of this driver and final circuit in this thing. So, yeah, extra channels, you don't get me wrong, you can get out of band some, but yeah, it's not like a standard radio. Don't expect to be getting a couple hundred channels, extra channels and still be having full output power out of one of these radios. Down here at the bottom, like I say, not a lot to it. Bridge rectifier, some filter, line filter caps there. Power supply board there. You can see there's some more bridge rectifier diodes down there. Pretty much everything here in this area here is all high voltage. So that's as far as don't want to electrocute yourself, this is the area you want to be careful in. The high voltage, the can caps right here, and then like I say, there's, what do we got? 1, 2, 3. Yeah, so there's one here, one there, and one there. Just a couple small axial lead high voltage caps. And that's pretty much it. They're nice radios, like I say. They're impressive. I've got a couple of them. I don't use them. For me personally, this is not mine, this is a customer's, but for me personally, I never use mine. They're just collector's items because they look cool on a shelf. I've got better radios, honestly. I've got better Cybernets, quite honestly, than this. The dual circuit board Cybernets, they're probably the best boards Cybernet ever came out with. And these boards are actually nice. Like I say, these things just have some inherent problems. Oh, actually, speaking of those boards, show you that part number. Yeah, put the camera up here far enough so you can see DT, what is that, 219, I think? Yeah, DT219M. And it's also over here. Oop, the camera again. DT219. So, yeah, it's not a PTBM board. Now, pass-throughs I was talking about. There are a boatload of them along the front edge. So, you'll see there's 2 rows going down the front here. The front or farthest towards the front row of pins, those go up to, those are actually the pins that stick up about that far out the top of the top of the board. Those are wire tie posts. The ones back here are the ones that attach those posts then to the circuitry. So it either traces on top or traces down here on the bottom side of the board. These are the ones a lot of times you'll have problems with, because these are those little ones, like I say, they kind of look like a cut-off nail, a little short nail. Best thing to do is I desolder both sides. So I'll desolder this. I'll actually just go through and I desolder all of them, resolder, apply some liquid flux, resolder all of them, and then I do the same thing on the top side. I'll desolder all of them, apply some liquid flux, and resolder them. It's just the best thing to do. The rest of them on the board, there's not a huge amount of them. Just look at them from the top side, see if they look like if any of them are broken. There was one in this one, somewhere in this area here, was questionable looking. Fix that. Other than that, the only other thing this radio really needed was one of the IF transformers for sideband. Sideband reception was just, yeah, it wasn't there. Bad IF can. So this is the second or third, I think it might be the third Canon sideband. It's the last one, but it's been replaced. It actually looks, I don't know if I can get this on camera or not. If I can get it to focus on this little guy. I'm just going to focus on everything in the background. Yeah, It's not going to focus on it. Well, yep, there we go. See that little plastic tube? See how it's kind of warped around there? That's what the core actually screws into. It looks like this at one point in time, because like I say, this radio's obviously had some work done to it over the years. I get the feeling somebody dead shorted either a pin right at the transformer can here or on one of the traces, because this can is like right here. It's actually, yeah, that's these, actually it's these right here. Those are all the solder connections for it. I get the feeling some of these terminals here, one of them was shorted to ground, because in sideband, which one is it? This terminal has like 6.5 volts on it, DC. So if you short this terminal or this terminal, you've just turned this thing into a heating element because it's no longer going, just feeding another circuit or dead ending in a cap or something. It's basically turned it into a heating coil, and it actually looks like that might be what happened, because I can't say I've ever really seen one of these little guys where that plastic was that deformed. I tried to pull it out to take a look at it. Well, yeah, there's no luck there. This actually has a ferrite glued on the outside of it, but the wires on this are actually fairly heavy, because usually these little cans, yeah, the wires on those things are almost microscopic in diameter. This one, not so much. They're actually, for the size, considering what it is, they're actually fairly heavy. You can even see them there, the little wires going up in the little tracks there. So it was able to survive apparently a dead short, but I get the feeling what probably happened was the enamel coating on the wire started to cook off. So a bunch of the windings are now shorted together, which of course changed the inductance of it, and that just completely threw the sideband receive out completely out of alignment for. But transmit was fine and AM was fine. So, yep, changed this little guy, and receive came back. Like I say, luckily have parts chassis, so I was able to. It's not like you're going to get one of these new anymore. So, there you go. There's just a quickie overview of the DAK 10. Like I say, they've got their downfalls, but they are nice radios. I like the cybernets. Like I say, people say they're high gain. Yeah, that's not high gain. I can just look at that and go, yep, cybernet. I mean, I've got dozens of radios personally, my own, exact same board, looks exactly the same, except it's not missing parts here and doesn't have that DT number. So yeah, it's now, could high gain have made it? I don't know. I didn't work for the M.H. Scott Company. I've never worked for High Gain, and I've never worked for Cybernet. So, to tell the honest truth, I can't tell you for sure, because I really don't know. I just know that's a Cybernet board by looking at it. Don't care what's printed on it or not printed on it. That's just a Cybernet board. Could maybe High Gain have subcontracted out and made them? It's possible. And High Gains were known for having some crap quality boards, so it is possible. I just don't think so. I can't see Cybernet. People that's what they did, made boards for companies, subletting that work out to somebody else. That would just make absolutely no sense whatsoever. So, get their flip back down here. Now, one thing that I guess is kind of sad with this radio, you can see it has a side-firing speaker right there. Well, it's got the slot right here. Why didn't they put another speaker in here? I don't know. You'd have thought if they're going to stick one over there, man, put one over here. You've got the audio power. But, wasn't meant to be, I guess. So, there you go. Like I say, nothing really fantastic to, unique in these. It's just a Cybernet, missing driver and final transistor. That's just tubes. So, pick your favorite Cybernet, one of your favorite Cybernet radios. That's basically what they did. They stuck it in a gigantic box with 2 vacuum tubes. So, now I can, already done the alignment on this, so all I need to do now is the final cleanup on this thing, do some scrubbing and polishing on the outside, pull all the knobs off, get them cleaned up. And these are the ones that had the plastic inserts. because you could get these solid aluminum, or later with the plastic. But I'll get all those cleaned up really good. The faceplate, there's nothing I'm going to be able to do for any scratches or anything, because this is brushed aluminum. And take my advice, don't ever try to polish this stuff in an attempt to remove scuffs like that, especially if it, even more so if it gets close to stuff that's silk screened on here. If you try to polish to even that out, for starters, you're probably going to remove the silk screened ink off the front. You're really screwed. The bigger problem is if you try to polish just one spot of brushed aluminum, you're going to make a shiny spot. Because this thing was just that, brushed. That's why it's called brushed aluminum. That's what it was. It's basically sanded. But in one direction only. That's why it has these streaks that run from one side to the other. If you try and polish that, you're going to make a bright shiny spot right here, and it's going to stick out like a sore thumb. It's going to look a hell of a lot worse than those, kind of, depending on what angle you look at it in the light, can be very inconspicuous lines. Trust me, if you make a shiny bright spot on brushed aluminum, yeah, it's going to look like crap. So just leave the little scratches like that alone. There's really not much you can do for them. Short of taking this faceplate off, removing everything from it, re-sanding the entire faceplate, so all the silk screening would be gone. So you'd have to basically re-brush finish the entire faceplate, and then re-silk screening the entire faceplate. There's really no way to get rid of that stuff without making it look worse than it already is. So there you go, the M.H. Scott Company DAK Mark X.